How good are you at the arithmetize strategy? Can you use it here? Is this a question where you can arithmetize? What do you think? You actually can. And the reason is that we don't really care how this p interacts with the x's. We just know, since it's the only unknown in here besides the x's, that if we got rid of the x's, wherever the p's kind of fall, that's going to be, we can solve for that, right? Because these are equivalent expressions, so we can set these things equal. So what I would do here is I would arithmetize. I know how to do the algebra. Maybe I'll show it to you at the end, but I would say let's make x equal to 1. I can't make it equal to 0 because then that would knock out the p's completely, so I don't want that. But I can make it equal to 1. That's going to make all this stuff now combinable. So just to kind of get to the main step here, 3 times 2 plus p plus 8 minus 16 times 1 or p plus 4. That's basically what I now have if I make x equal to 1. And a lot of this can be combined, right? So this is 3 times 10 plus p minus 16 times p plus 4. So that's 30 plus 3p minus 16p minus 64. 16 times 4? Yep, 64. So again, we can combine. So this and this would become, well, let's actually do the p's first, right? So 3p minus 16p is negative 13p, and then this is minus 34. And that's equal to this thing, which we're also putting x for 1 in there, right? So this is really 6 minus 155 plus 24. So 6 minus 155 plus 24 is negative 125. So notice it ends up just being kind of a solve for x situation now. We could go to Desmos with that, but I don't think it's much harder to just do this. So plus 34 is negative 91. That is equal to negative 13p. Let's divide by negative 13. We also could have just guessed and checked at a certain point here, but that's fine. Divided by negative 13 is 7. And is that an answer? Yes. Is that the answer? Yes. So that works. Now, I get that this looks like a lot of other questions that I've done that I wasn't able to arithmetize. So what gives? Why is it different? Well, notice that the p here doesn't line up with anything in the other equation. It's not something that is very specific to a term. And there aren't multiple unknowns here. It's not like there's a p and a q and an r and we've got to specifically find the p. It's that there's only p's, right? So we're allowed to basically erase all of the terms by making x equal to 1, let them all just kind of mush together, and then whatever is left is something we can solve for. This, I think, is a really good thing to think about, is maybe, yes, the algebra here wasn't so bad if you just did it by hand, but being able to know when we can use the strategies and we can't, even in very weird situations. That's kind of the point of this entire exercise, is to get you thinking in new ways. Maybe it's not efficient to arithmetize in your mind, but as long as you're starting to think about those strategies, there will be cases when you are stuck on something, when you're now able to use the strategy more confidently because you understand how it works and why it works. If we wanted to do the algebra, just for those of you who really care, just do what you're told. Distribute this. We get 6x squared plus 3px plus 24 minus 16px minus 64x. And so now I can kind of see what's going on. The p's are all on this x term. So all of these need to be combined in some way. And that's going to mean I need to think about the x term in the other one. So this is where maybe a shortcut happens, is 3px minus 16px minus 64x is equal to negative 155x. We can drop all the x's, combine like terms, so we get negative 13p minus 64 is equal to negative 155. This is a little different than we had before, so let's add the 64, Negative 13p is equal to negative 155 plus 64 is negative 91. Divide by negative 13, divide by negative 13. We did that there, so p is still 7. I don't know. Not so bad for algebra, but I don't know. There's a lot of things going on. You've got p's and x's, and I can tell what's going to happen is some of you are going to lose an x or two because you're thinking of the p as the variable and not the x. It's going to happen, especially right here in this step. Comment if I'm right. If you messed it up, I bet that when you distributed that negative 16x, you lost an x somewhere. In fact, I would bet that you instead of having negative 64x right here, you just had negative 64. And that might have allowed for some sort of error. So I'm curious, I'm not going to bother with it, but I'm curious if that is an error that you made and if it got you a right answer, or it got you an answer here so that you thought you were right when you were wrong. I'm very curious if that ends up happening. But yeah, hopefully now you know another reason we can arithmetize and other sorts of weird situations where that's going to work.